right now, like as you listen to this, your biological operating system is quietly calculating whether or not you are in mortal danger.
Oh, wow.
Yeah, it's analyzing threats, managing your heart rate, and prepping your muscles for explosive movement. And, well, you aren't even lifting a finger.
It's basically the ultimate background software.
Mhm.
And today I am happily playing the role of the student, just throwing questions at you to figure out the code behind this system.
And I am putting on the tweed jacket to be your lecturer.
Ugh.
So our guide for this deep dive is section 3.3 of chapter 3 from Psychology 2E.
Right.
And the mission is to explore how the nervous system hardwires you for survival and why it sometimes spectacularly misfires in the modern world.
Yeah, which is super relatable. So,
Mhm.
I mean, skipping the basic anatomy, we know the central nervous system is the command center. But how does the peripheral nervous system actually execute the orders?
Well, it splits the workload. You have the somatic system, which handles the conscious voluntary stuff.
Mm.
And the textbook actually uses a simple memory trick for the traffic here. Efferent fibers, they exit the central system. So those are like motor neurons telling your hand to move.
Oh, right. And afferent fibers arrive, so they carry the sensory data back.
Precisely. They bring
Wow.
the data back.
Okay, so the somatic system is like you consciously deciding to click play on this deep dive. But what about the autonomic system? I'm assuming that's the background software keeping my lungs expanding while I'm distracted by the audio.
Yeah, exactly. But it's not just a passive life support system. It is actively scanning for threats.
Oh, wait, if it's scanning for threats, how does it physically pivot from, just managing my breathing to keeping me from getting eaten?
So that is where the autonomic system splits again.
Oh, okay.
The parasympathetic side is your routine rest and digest mode, but the sympathetic division, that's your emergency response team.
Right.
Section 3.3 uses this classic ancestor in the bear scenario.
There.
You disturb a massive bear in the woods, and the sympathetic system instantly overrides everything to trigger a fight-or-flight response.
Yeah. Right, but let's dig into the how and why here. Like, it's not just a generic panic attack, it's a highly coordinated physiological shift. What is actually happening under the hood?
Well, it's all about maximizing immediate physical performance. Your pupils dilate. And why? To let in more light, so your visual field expands to see the threat clearly.
Wow, okay.
Yeah, and your liver instantly dumps massive amounts of glucose into your bloodstream. That's not random. Your muscles need explosive combustible energy right then to sprint.
That makes sense.
Even your bladder relaxes. Which sounds counterintuitive, but it's an evolutionary trick to shed excess weight quickly.
Oh, shedding weight to run faster makes perfect evolutionary sense. But I mean, here's the problem for you listening. You're probably not hunting bears.
Right.
So why does this archaic survival mechanism matter when you're just, sitting in an office?
Because our hardware hasn't updated to match our modern reality. When you stand up to give a high-stakes presentation in a boardroom or open an aggressive email, your brain perceives a psychological threat.
Oh, I see.
But your autonomic nervous system only has one emergency protocol. It treats that boardroom exactly like the bear.
So your liver is dumping glucose and your pupils are dilating just to read an email.
Yeah.
Wow. If that fight or flight switch gets flipped constantly by office stress, it has to cause physical damage over time.
Oh, it causes severe wear and tear.
Mm-hmm.
Chronic exposure to these perceived threats keeps your body in a constant state of alarm.
Right.
The result, you become highly susceptible to heart disease and your immune system gets suppressed. Your body's diverting all its resources to surviving the immediate bear attack and completely neglecting long-term cellular maintenance.
Jeez. So if the sympathetic system is mashing the gas pedal, how do we hit the brakes? Obviously, the body has a mechanism to clean up this biochemical mess once the presentation is over.
Yeah, so that's when the parasympathetic system finally takes the wheel back. Its entire job is to restore homeostasis.
Which is like a balanced state of internal equilibrium, right?
Exactly. It physically reverses the emergency protocol. It constricts those dilated pupils, slows your racing heart, and commands the liver to stop dumping glucose and start storing it as glycogen again.
So it puts the body back into maintenance mode. Looking at this whole dynamic, it's a brilliant setup for a world of physical danger. It's just tragically mismatched for a world where threats are mostly psychological.
That is the ultimate takeaway here. Your nervous system is a masterpiece of ancient engineering, flawlessly designed to save your life, but hopelessly confused by modern stress.
Which raises a highly practical question to leave you with. Since your biology physically cannot tell the difference between a charging predator and a calendar notification, well, How might you consciously hack your own background software to signal to your autonomic nervous system that you are, in fact, safe?
Definitely something to experiment with the next time your heart rate spikes over a text message.